In the previous videos, we discussed variables in a very abstract way. So we've made variables such as Fred equals 2, Gina equals 5, which, as you know, essentially means that we're creating an essential box called Fred that holds the number 2, an essential box called Gina that holds the number 5. Now, why on earth would we want such boxes? Why would we have a box called Gina that holds the number 5? So now I'm going to show you how variables may be used more realistically in day-to-day code. So let's write some code that simulates the purchasing of items at a convenience store. So let's say that we're going to set the prices for some various items. So let's say that an apple costs 50 cents, a banana costs $1, and a gallon of milk costs $2.50. Next, we're going to calculate the total of a person's bill based on the quantities of the items that the person buys. So we're going to make a variable called subtotal. I'm not jumping to the total yet because we're going to have to account for tax. So let's say, for example, that a person buys 2 apples. The subtotal will be apple, which again is the contents of apple, which is 50 cents, times 2. So if the person bought 2 apples, their subtotal should be $1. Now at this point, what would happen if I hit the play button? As you know, nothing will happen because I've never explicitly told Ruby to display anything anywhere in the terminal. So we must explicitly go ahead and say p subtotal. And as you can see, we get the number 1.0, which indicates that at this point the subtotal is $1. Now let's say the customer also bought 3 bananas. This is where we may need to start accounting for our order of operations. So we're going to wrap apple times 2 in parentheses. So the person is buying 2 apples, but they're also buying 3 bananas. At this point, if we hit the play button, we can see that their subtotal is $4. Now let's say they also went ahead and bought 2 gallons of milk. We can see that their subtotal is $9. So in this example, you could see that the variables that we're creating represent real-life things. Our variables of apple, banana, and milk represent the prices of those items. The subtotal variable represents the subtotal price that a customer would have to pay based on the quantities of the various items that they've purchased. Now let's account for tax. Let's say that the standard sales tax rate is 9%. So we're going to say tax, we're creating a variable called tax. The tax that a person would have to pay is the subtotal multiplied by 0.09 if, again, the tax rate was 9%. So we could print the subtotal to the terminal. We could also print the tax to the terminal. So if we hit the play button, we can see that their subtotal is $9. Their tax is about 81 cents. So let's finally calculate their total. We're going to create a variable called total, which is simply going to be the sum of their subtotal plus the tax. And if we print the total to the terminal, we can see that this person is paying $9.81. What's really cool about our code is that all of it is still relevant even if various changes to a customer's purchase are made. So let's say a person decides to buy 4 apples instead of 2. All we need to do is change that quantity of apple times 2 to apple times 4, and then we hit the play button, and boom, we have our new calculation, and we can see that their total is $10.90. Similarly, let's say the price of something changes. So let's say milk now costs $3 instead of $2.50. We can simply change that milk variable, and the rest of the software can remain intact and perform the appropriate calculation. So we can just hit the play button at this point, and we can see that this customer needs to pay $11.99. But what I really wanted to do in this video is give you a sense of how variables might be used in real software.